job?
How do I get a job?
How do I get your
Yes,
job?
Stirrup, how do we get your job?
How do I?
For a day, can we be the subs?
Can we teach you, like, modern terms or something? I don't know.
Like on,
Like, put the fries in the bag, bro.
on
Gotcha.
All right. Yeah, we can teach them how to play beer.
Yeah, see, after we missed the knuckle.
Beer's a loyalty.
All right. So did y'all find that page in the book?
Yeah.
All right. So let's kind of make some things to define. All right. So this is a box plot. Desmos will indeed do a box plot. Box plot does not give you the mean. Okay? Now it'll give you kind of an indication, bless you. It'll give you an indication basically where the mean is about somewhere. So a few things to know. These all represent 25% of our data. Okay, it doesn't give you what your data is. It's just that 25%. And if you recall, there's kind of a dispute. Does an outlier fit into that final 25%? And I kid you not, about half the statisticians will say yes and half will say no. So they have no idea. I have no idea. So if you leave it as one of it and you do data, then I will recognize that. If you don't leave it, I will also recognize that you left it out, and that's fine. Important things about this. This is the median. Sometimes they will call this Q2. The edge right here is called Q1. Over here is Q3. And then there was this term that if we talk about just this region here, this is called the IQR, which is the interquartile range, which is Q3 minus Q1. And a lot of times you might have to look at a graph to see approximately where it fits. The graph that we have on our book on 1-9, you kind of have to guesstimate. And I get that you have to guesstimate. So if your answer was off a smidge, that's okay. But this is all things that take care of our data. Now, if you look at this, this example here appears that it is skew right. And the reason it appears to be skew right is a couple of things. This rectangle between the median and Q3 is a larger rectangle than the rectangle between Q1 and the median. It appears that this whisker is further out. So those are two indicators that it's skew right. And if it's skew right, that means that our mean is going to be larger than our median. But I don't know what the mean is going to be. I just know that my mean is going to be to the right of my median in this situation. Now, if your box plot is totally symmetric, like the whiskers are the same length, the rectangles within the big rectangle are the same size, that would say that your data is relatively normal. If it's relatively normal, that means your mean and a median are basically the same number. Okay, it doesn't mean they're exact. They're basically the same number. They could very much be exact, especially when we're dealing with small data sets. But if you had a really large data set and you're looking at something like this, if your mean was slightly bigger or slightly smaller than the mean, it doesn't necessarily mean a skewness. There's an arbitrary thing of just a small thing of problems. Okay, so you have 4 quartiles. Again, some statisticians will say that the outlier will be part of the upper or lower quartile, and some will say it isn't. I don't know what the exact answer is. It becomes really one of those things that if you were to look it up, if you find one that says it's against, you'll find just as many that'll say that it's for. So it's kind of a silly thing. I just wish they could get together and actually, I don't know. I hope they don't invite me to that session because that would be kind of boring. All right. So the big thing when you're dealing with the quartiles, Dee and I deal with 50% of my data between Q3 and Q1. So that's close to 1 standard deviation. 1 standard deviation, remember, standard deviation goes with the mean. A standard deviation, 1 standard deviation is the average distance away from the mean, which talks about 68%. So the Q3 and Q1 are inside of the standard deviation. But again, standard deviation goes along with when you're talking about a mean. When you're talking about medians, you're talking about a box plot. Okay, have I lost anybody so far, or we feel okay? Then at the very bottom of that page for 1-9, it talks about the 5-number summary. 5-number summary takes place like this. So let's pick a, ooh, we're going to go with a nice pink. Oh, that's so pretty. All right. This is a min. This is basically a max. Yes, that outlier could indeed be the max, but just for what we're doing right now, we're fine saying that. If I give you a 5-number summary, it tells you basically what your graph looks like. Summary. 5-number summary. Did I spell summary right or wrong? SUMMARY. I did. I spelled it right. So if they gave you like numbers like this, 5, 7, 10, 15, and 18, this is your min. This is your max. And then this is Q1, Q3, median. And again, the median sometimes might be called Q2. Okay? So your 5-number summary only gives you a basic look at your data, what it would look like if you were to have a box and whiskers. It tells you nothing about your data. It might tell you, it might indicate that you have skewness right, left, or even normal if the spacing between the numbers is done. But those are the basics of a box plot or box and whiskers plot. Okay. All right, I'm on to the next page. And we've already talked about this a little bit. Determining the shape of distribution sometimes can be tricky. So let's talk about how you might see skew right, skew left, and normal. And I'm going to take this off so I can. So I'm going to draw one that I would think might be somewhat normal. This might be normal if this had a 5-number summary. If this was 5, this was 8, this was 10, this was 12, and this was 17. Basically looking at the distances. Actually, I'm going to make that a 15. Things that I'm looking at. There's a distance of 3 here, distance of 3 here. Okay? That right there indicates that we're not dealing with outliers. The distance between these are both 2 and 2. So this could be a very normal distribution if we were looking at it. This example is not given. I'm just writing you one that kind of looks like it. But if you look at something like that, things that this could tell you that the mean is about the same as the median because there wasn't any skewness. Okay, and those are just some things to look at. And a lot of times when you're doing statistics, you're looking at the picture, and the picture is telling you some information about what the graph is doing. Let's take a look at a skew right. So a couple things. I'm going to draw 2 things in place. Actually, I'm going to draw you 3 things in place. All of those are skew right as far as the data is saying. So this is larger, this is larger, and this is larger and larger. That just means that my mean is going to be a larger number than my median. Okay? Skew right. Remember, as far as skewness goes, the mean gets pulled the direction of the skew. Okay? The reason I wanted to draw this is that these 2 rectangles look to be about the same size on the very first one, where I have this long whisker coming off. So that's telling you I'm pulling my mean to the right. This one, it appears that my 2 whiskers are relatively the same size. I just pretend I could draw really well. Where I have a rectangle on the right that's larger. And then the last one, I have a larger rectangle on the right, and I also have a larger whisker to the right. So those are all things that would indicate that you have skew right data. Does that make sense? And this is just backwards if I go skew left. Skew left. Try and do something nice and it didn't work. So these are all skew left because this is larger over here, or this is larger here, or they're both larger, depending upon your data. And if this takes place, your mean is less than your median. And then the last thing I just want to circle back and just talk about real quick is when we have the 5-number summary given, your 5-number summary does not tell us a mean on all of these. If it was a normal distribution, that means my mean is about the same as the median. On the skew right, that means that my mean is going to fall to the right of the median. So on any of those red ones, and then on the green ones, if it's skew left, my mean is going to be pulled to the left because that's where the larger areas are going. All right, so 5-number summary. This does not tell you your data at all. It just tells you what your picture is going to look like. All right. So somebody give me a shout out. What's my median?
15.
15? Good. What is my Q1? 8. What is my Q3?
30.
What is my maximum?
40.
40. And my minimum?
2.
2. Now, it's very possible that the 40 or the 2 could be outliers. There's a test that we will do to figure out if it is truly an outlier or not, but we're not quite there yet. But if they ask you to draw something like this, I always kind of like to start saying, okay, I'm going from 2 to 40. I'd say 30 is about there. 15 is probably down here. 8's probably here. That's my box and whiskers to it. Anyone want to tell me if this is normal, skew right, or skew left? Skew right. I have a bigger rectangle to the right. My mean would be pulled to the right. Things that you could tell about how skewedness takes place. This has a distance of 6. This has a distance of 7. This has a distance of 15. This has a distance of 10. So there's lots of things that kind of tell you. The green is just the distance. That's not actually any data points. It's just showing you how far from one segment to the next it would go. Now, Desmos won't graph your 5-number summary. If you just have a 5-number summary, you go to Desmos to try graph it, it's not going to work. I will warn you, we'll have a quiz at some point. I haven't looked too much further in advance to know when it's going to be. I think I'll actually be here for a change, which is kind of fun. So that 5-number summary, a lot of students, I'll give the 5-number summary, they'll plug it into Desmos and go on, this is what my picture looks like. The 5-number summary, you have to just draw the best you can. I'm not looking for art. If we were doing that, I clearly fail. You know, if I had a 10-point assignment and you were grading me for art, you got a STRP, you got a 1/16th of a point. Nice. But let's take a look at Desmos and see how this is going to work when I actually have data that was given. All right. Did it work for me? Yay. Hey, there's my email. Good.
Mini quiz.
That's for Algebra 1. Shh, don't tell them. But you could tell them at 14 minutes and 48 seconds, there was a quick glance at the quiz. All right. So 5 numbers, or this can all be done on Desmos. Let's just make up some values. All right, so I just made up some data. I didn't get this from anywhere. But what you can do is you can go and look for, under functions, you can look for box plot. So if you see it before me, let me know.
I found it.
Box plot, found it too. Box plot, X1. Once you have it in there, hit the plus button, and then you can zoom in. All right, and let's make this darker so we can capture the moment with perfection. Friends, what do you think that dot out of 20 means? It is an outlier, okay? So Desmos will indeed do the outliers. If it doesn't want you to focus on outliers right now, you could say exclude outlier, and it just makes your line the entire length, okay? So now we are into some problems with Stirrup's data. Okay. So what should we do here? Is it skew right or is it skew left?
I think it's balanced. Maybe you're right.
So here's the tough thing. Is that tail, is the whisker on the right bigger than the whisker on the left?
Yes.
Okay, so that might indicate skew right. All of a sudden I come to this rectangle, the rectangle's here, and I have, this is a larger rectangle, the left rectangle is larger than the one on the right, which if you're only looking at that, would say it's skew left. So what is the answer? And this is the only way you can find the answer, and I wouldn't give you a 5-number summary that would do something like this, where it's one or the other. Because what did I say that you can't see on a box whiskers? I can't see the mean. Now, did I plug data in order to get this picture? Yeah. So what I'm going to do is I'm not sure just by looking at it if it's skew right or skew left. So, but because I did plug data in, we can come down here and let's type in, I want the mean of X1. And I also want the median. Go away. I also want the median of X1. And this will indicate what it's doing. Okay, so I have a mean of 7.9. I have a median of 8. The mean gets pulled the direction of skewness. So looking at that, is the mean a larger number or a smaller number than the mean?
What?
Is the mean smaller or bigger than the median?
Smaller.
Smaller. So that tells you this is skew left. Okay? Now, we also can't see our data as it sits to know if it truly is. I mean, 7.9 and 8 are two really close numbers to each other. Is that close enough to say this could be a normal distribution? And the answer is we don't know that at this point. You'd actually have to create the normal distribution and take a look at it and verify if 68% of your data fell in between one standard deviation, which again, we're not there yet. But as of right now, this question, if this was a written question on a test, there's all kinds of arguments that you could make. You know, you could tell me visually it appears that the whisker to the right is bigger and there's an outlier out to the right, so it's got to be skew right. Okay, that's a pretty valid argument, and I think you might be right. But you might, person that you're in your group that you're sharing, comparing, and revising with might say, no, the rectangle on the left is bigger than the rectangle on the right, so I believe this is skew left. And I'm like, oh, okay, it might be skew left. And that person might be right. And then you have the person who went really upon themselves and said, I paid attention on that Monday when Sturp was talking. I don't know how because I only have one eye open. But I see that the mean is smaller than the median, so it's got to be skew left. And that person might be right. And then you might get the other person saying, no, the mean and the median are so close to each other, there might not be skewness at all. And that person might be right. Holy cow. I just gave you like all kinds of right answers that it could be, and they're all completely different answers. So a lot of times in stats, from here on out to any statistics, if you can justify an answer, you're right. So what's the answer? Everything I just said. I don't know for sure. Okay? The only other way to try it, once you get there, is make the normal distribution and figure out the standard deviation and figure out if you had 68% of your data fall within that first standard deviation. But we're not there yet. So there's all kinds of funny stuff that could take place. Again, Desmos becomes very healthy for you. If you look at this is if you were using the graphing calculator. Graphing calculator, there's a whole lot more steps to find that. If you were looking at this and you wanted to figure out what your min was, well, this appears it's counting by 2's in the x direction. So a minimum would be 2, 4 would be Q1. Our median, which we already found, looks like it's 8. Our Q3 is 10. And then depending if I use the outliers or not, I might have a max of 20 or I might have a max of 16, and you'd be correct in all of those scenarios. So it's just kind of a wild ride, and I don't know if it bothers you that if you're in a class that lots of answers could be correct as long as you can justify it. Okay? Don't be the Chris Sturp, this guy. Why did this happen? Because. Well, that's not an answer. No, it's an answer. I wrote because. No, that's Chris. That's not an answer. No, I wrote because. That's my answer. Okay, I don't know if any of you were that ding dong when you were in elementary school like me, but that's how I was. And I also was the guy that would make the true false, you make your T and your F look kind of similar. So if your teacher said, no, that should be true. No, that is a T. That's how I make my T's. And then for the next week, you try and make your T's look like that so your teacher believes your lie. I don't know if any of you done that too, but that's who I was too. I mean, I tried to figure out the system and I didn't figure it out. I'm still lost. So, but I have fun doing what I'm doing because I'm lost. But your assignment, I'll give you the rest of the time to work on, is 1-9. I don't know what page it is.
125.
How much?
It's 123.
123? Cool. So go with that, and you kind of have to guesstimate it. So page 123, it's just the front and back, I believe. Maybe it's just the front, I don't know.
No.
That's the front and back. Ooh, and then we have a review. That means I have a quiz coming up. When do you guys want to do a quiz? Never? Okay.
Let's do it over the weekend.
Over the weekend. Over the
Let's have
weekend.
Sturp do it all for us.
Okay, Sturp,
And that's like a lottery thing. You gotta lose like